Alright, we're going to pick up the pace here. Hopefully from now on it won't be as boring talking about stuff that nobody knows, like cations, anions, and soil solution, and colloids, can't talk, and colloid solutions. But as we progress through this, you'll understand why I put that in there, so that you have an understanding of exactly what's going on. We'll talk about something that everybody now knows a little bit better, pH. pH stands for potential hydrogen. It's a -10 logarithmic function, which means that every time we go down or we go up from a given number, it is going to be the powers of 10. Alright? So that means that if we go from 6 to 5, that's 10 times lower than 6. If we're at a 3, that is 10, 100, 1,000 times lower than 6. Alright? 10,000, 100,000, you keep on going. If you notice the way I've sketched this out here, 1 being the lowest is a 0.1 number to represent the pH. And what they do is they take this probe, it's a standard probe that they use, that detects hydrogen, and this is the math and formula they use to represent it. So when you see 1, it's 0.1 hydrogen. When you see 6, it is shifted over 5 zeros and 1 to make it 6 places from the decimal. Now I'm going to provide some links here. I'm trying not to make this complicated and let you go and read. I mean, I could explain this in detail, but to make the video longer than I want to. So I'm going to give you sites and references, and you can go and look it up yourself, and you'll understand what I'm trying to tell you here. The biggest thing I want you to understand is why it's -10 logarithmic, and why it's set up the way it is, and why 3 is 1,000 times more acidic than 6, just like 9 is 1,000 times more alkaline than 6. Alright? So in a previous video I was telling you the way we correct pH. A lot of people think, well, we just remove stuff. No, we can't do that. Remember, these both are positive charged cations. Alright? That soil is negative charged. I mean, that's like putting two magnets together. It's going to stick. Minus some type of chemical reaction or you know, something at the nuclear level, you're not going to break those bonds. So what we have to do is attempt to displace the hydrogen. In this sense, when I say the context of displace, I mean put more of something else that is there than the other, so that the other doesn't show up as much. In this case, I'm going to put more calcium in so that the hydrogen doesn't show up. In effect, I'm attempting to neutralize and overrun the hydrogen. So take our soil sample here. This is a piece of soil from a soil sample we took at a pH of 4. And I've used 12 dots to represent what 4 would mean. This is not what it's going to be, but for the sake of this video, we're going to say that 4 blue dots is a pH of 4 in hydrogen. Okay? There's 1, 2, 3, 4, 5, 6, 7 green calcium cations. Again, representative, not necessarily fact. This is just an example. Now, this spring, I put solucal down and lined my soil. And you can count, they're going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 hydrogen cations from that same soil. I didn't take the hydrogen off. But look how much more calcium I've got there compared to this guy. It's probably 10 times more. Don't know, I didn't count, I just sketched on there. What happens is when that etching, not etching, excuse me, I'm thinking about painting right now. The solution that they use to extract the nutrients off the soil to test it. When it pulls this one, it's not going to have as many calcium to pull, and it's going to have more hydrogen, so the hydrogen is going to be more prevalent. When they do it on this one, there's going to be a lot more calcium that's going to come off than it is hydrogen, so the hydrogen is not going to be there as much. Same thing happens. Remember I told you about the soil solution, the caloric solution. Same thing. Less of the hydrogen is going to be there to come off, but more calcium is going to be there to counteract the acidic effects of hydrogen. Okay? So that's what happens when you are attempting to change the pH of your soil. Now, if you remember the other video we were talking about the cations, we said that calcium had to be 68% and hydrogen had to be 10%. Well, that might be a fair, maybe you give me 68%. Let's say 50. Let's say 50 and it's 15% hydrogen. Let's just say that because, I didn't count it. And this guy right here, it's basically, you might say 40% calcium because I've only got, 1, 2, 3, 4, 5, 6, 7 calciums and 12 hydrogen. So I've got far more hydrogen percentage-wise than I do calcium. So when we get to the balanced soil and we get that calcium and that magnesium and that listen to me, magnesium, hydrogen in those two percentages, then we don't have to start worrying about pH so much because they're taking care of themselves. They're in harmony. Just like this guy right here. Okay? So, hope that kind of helps some of this. I'm trying not to make these videos a little more boring than I have to. I really am. I don't want you to be bored. I want you to actually learn something. The other two I knew were going to be boring. I knew that. They were boring for me. But going forward, I'm hoping to make them more shorter, condensed, and with stuff that's actually going to make sense to you that you see now. We shouldn't be talking about things you don't know. Looking at my board, I don't see anything that is going to stick out like the last two. But I'm doing this to help y'all. So if it's something you need to know, if I'm not saying something, I get things in my head but I can't get them out right. That's just one of my problems. Put it in the comment. You're not going to hurt my feelings. I want to know these things because I'm doing this to help you. And look for the citations because I want you to be able to quantify what I'm saying. I want you to be able to do your own research. That's the other part of this is I don't want you to have to just take my word for it. I want you to have the tools to go out there and get it and figure it out yourselves. So, stay tuned. See you on the next one.